In this lesson, we're going to continue to play with relationships, looking at graphs and tables and equations and how we can go from one to the other. But we're going to try to concentrate more on graphs today. So working with graphs. So no new content, just some examples. Play with those examples. So let's take a look at the first one. The total cost of a field trip to a museum has no initial fee. Well, that's kind of important information, right? And it's made up of $10 per student for entrance to the museum and $5 per student for the bus. Well, there's actually kind of two rates here. But if I put them together, my rate for each student will be $15 per student. So what do I got? No initial fee and a rate of 15. Well, that's pretty important stuff. Which of the following graphs could represent the relationship between the total cost of the field trip and the number of students? Well, I think the fact that we have no initial fee narrows this down right off the bat a little bit. I know it can't be C because this one has an initial fee of $5. It can't be D, it's got an initial value of $10. So it's got to be A or B. Okay, what else do we have? Well, it's going up $15 per student. So if I thought about that, no students, $0. Okay, this is students. This is my cost. For one student, it's going to cost us $15. Which of these has the cost of one student being $15? It looks like 115 is right there. This one student costs $10. Gotta be A. It's the only one that actually matches. Okay, so taking some information from our question and analyzing which graph makes the most sense. Let's try another one. We got Marissa. She owns a repair shop. She charges an initial fee and a cost per hour. Okay, so we need to have an initial fee this time and a rate. For 1 hour, the total cost is 80, and for 2 hours, the total cost is 100. Okay, so I'm thinking about time, number of hours, and cost. And I know that 1 hour is 80, 2 hours is 100. I know there's an initial fee, so let's figure out what that would be. What's the pattern to my table? Well, it seems like it went up 1 hour and went up 20. So for every hour it must be $20, which means if I go backwards, that has to be 60, right, to follow the pattern. Okay, plus 20, plus 20, plus 1, plus 1. There's my table. Okay, what type of variation is a relationship? Well, I know that. I have an initial value, so it has to be partial. Get rid of those ones. And what is the initial value? Well, we just figured that out, that it's $60. And the trick question is saying it's 80 because that's what it says it starts at. But that's already 1 hour. We know initial value starts at 0. So no graph that time, but thinking. A gym charges a membership fee for students and a cost per visit, as shown by this graph. So a membership fee is my initial, and a cost per visit is my rate. Okay. So I got myself a graph here. What else do they want? The gym increases the membership fee by $10. Oh, and decreases the cost per visit by $1. Which of the equations represents the new cost? Okay, well, to figure out the new one, I got to figure out the old one. So what was my old initial value? It looks like it started at 15. And what do we want to do to that? We want to increase the membership by 10. Okay, so I know my cost has to start at, if it was 15, and we go up by 10, it's got to be 25. So it can't be this one, and it can't be this one. What else do they do? They decrease the cost per visit, the rate, by $1. Well, let's find the old rate. Make ourselves a triangle here. I have to go up from 15 to 25, so that's up 10. Up 10 and over, went over to 2. So over 2. So $10 for every 2 visits comes out to $5 per visit. And what do we want to do to that? We want to decrease our cost by $1. So instead of 5, now it's going to be $4 per visit. Well, which equation is that one? There it is right there. Taking information from our graph and changing it this time. So what do you think about that one? I got one more for you. The total cost to deliver a package with Quick Post is shown by the graph. Okay, I got myself an initial value right there. I can figure out a rate if I need it. Oh, write an equation. That's kind of our standard thing, right? So let's move this over a little bit here. That guy goes over here. Okay, our initial value is 15. Let's make ourselves a nice triangle. That looks like a nice dot right there. Up 5 over to 100. Okay, rate equals up 5 over 100. Missed my word there. 5 what? I think this was $5 it says. Total cost, yep. 100 what? 100 kilometers. If I divide that, it costs me 5 cents per kilometer. Okay, let's make our equation. Same old things we usually do. X equals number of kilometers. Y is cost. Okay, on our graph we said the initial value was 15. Right, plus, it's going up 5 cents for every kilometer we go. Okay, there's A done. Let's try B. The total cost to deliver a package with Post Packages, so a different company, is made up of a $10 initial fee and 10 cents per kilometer. Okay, so if I want to write that as an equation, that would be 10 plus 0.1x. But they don't want an equation, they actually want us to add this relation to the graph. So how can we do that? Well, definitely know where 10 is. That's right there. That's my initial value. But I need some more dots. So how can I get more dots? Well, I have this beautiful equation, right? I can find as many dots as I want to by figuring out different kilometers to use for x. Now, nice numbers would be something like 100 or 200 or 300. I could use the 50s too, but I think 100 is actually a nicer number to work with. Let's see what happens. If x was 100 kilometers, because x is my distance, I'm going to end up with y equals 10 plus 0.1 times 100, or in other words, 10 plus 10, 20 bucks. When I go 100 kilometers, it costs me $20. So 120, there's another dot. If I wanted another one, what could I do? Well, let's make x be 200 kilometers. Let's use our exact same equation. We're going to make x be 200 this time. We'll get 10 plus 20. That's 30 bucks. 200 kilometers is 30 bucks. 200 is 30. In fact, if you stop and look at it and think of this as a table, because tables are really handy, okay? Number of kilometers cost. We know 0, initial value was 10. 100 kilometers, we just figured out was 20 bucks. 200 kilometers is 30 bucks. Well, I bet I can guess that 300 kilometers there's a pattern here. I bet it's 40 bucks, sorry, and 400 is 50. And if I add those to my graph, just for fun, 300 is 40. 300 is 40. Well, doesn't that follow my pattern perfectly in a nice straight line? I mean, that's kind of the idea. These all should make nice straight lines. Okay, so we did B. What was the question for C here? How much more will it cost to deliver a package a distance of 250 kilometers with Post than it does with Quick Post? Well, we have equations. Equations are really handy things. So, part C. Our first equation for, what was this first one called? I think it was called Quick Post. Is this thing right here. Quick Post. I'm going to call it QP. I'm just going to write it down so I can see it down here, okay? It's 15 plus 0.05x, I think. 15 plus 0.0, yeah. Okay, and the other one was Post Packages. It had a different equation. It was 10 plus 0.1x. Right, that's one we just had right here. Yep, there it is. Okay, what am I trying to figure out? I'm trying to figure out the difference in a distance of 240 250 kilometers. Just move it over here so we can do this easier at the same time. Well, 250 kilometers is my x. If x is 250, I can put it in here for x. And we can do some math. I'm going to get 15 plus 12.5, or in other words, $27.50 for the first company. If I do the exact same thing in the other one, but use the other equation, I'll get 10 plus 25, or in other words, $35. The question wanted to know how much more will it cost? Well, it definitely costs more, right? 35 is bigger than 27.50, but by how much? Well, let's subtract and find out. Oh. It will cost $7.50 more with, which company was it? Let's go back up to the top. Oh, went too far. Sorry, guys. Our company was Post Packages. And we're done. Again, there's nothing new today. It's about playing with graphs and finding things we can recognize. Same things over and over again, but we just want to try different kinds of questions, worded in different ways or given different information. Hey, try this sheet. If you're stuck, come see me.